A source of EMF 240 volts and frequency 50 Hz is connected to a series arrangement of a resistor, an inductor, and a capacitor. When the current in the capacitor is 10 ampere, the potential difference across the resistor is 140 volts, and that across the inductor is 50 volts. I calculate the potential difference across the capacitor, capacitance of the capacitor, inductance of inductor. This is the circuit diagram of the situation. This is a resistor, which is given. We have the resistor, and then we have the inductor and the capacitor. This is the source voltage. It's giving us 240 root mean square volts, and the frequency is 50 Hz. And from the question, we have the current, the root mean square current that flows in the circuit. It's giving us 10 ampere. Then we have the potential, the voltage across the resistor is 140 volts. We have that here, that is VR. The voltage across the inductor is 50 volts. That would be here, VL. We have to calculate the potential difference across the capacitor, which we don't know. Not BC, don't know. From the source voltage, this is an AC circuit. Using vector diagram, the source voltage mean square voltage, the square of it is equal to the voltage, the square of the voltage across the resistor plus voltage of the inductor across the inductor minus the voltage across the capacitor. Our emphasis to find C. The source voltage is given as 240 volts. These have been given to us 140 square. We have VL, that is 50 volts. VC is unknown. We can rearrange this equation to have 50 minus VC square is equals to 240 square minus 140 square. And this can be analyzed to give, using a calculator, 38,000. From here, you can get rid of the square root sign as 50 VC is equals to plus or minus square root of 38,000. And make VC the circuit of formula. We will have 50 plus or minus square root of 38,000. Approximately the square root of 38,000 is 194.9. And we are taking the positive value. That is the VC is equals to 50 plus 194.9. That will give us 244.9 approximately, which is 245 volts, the voltage across the capacitor. The next question is to calculate the capacitance of the capacitor. The capacitance of the capacitor. We will say that C, we're looking for C, the capacitance of the capacitor. The voltage across the capacitor is given by the expression the current times capacitive reactance. The reactance. And here we have can make XC the subject formula. VC all over I. Put in a value. We calculated VC to be 245, and I, the current, has been given as 10. That's when we divide that, that should give us 24.5 volts. 24.5 volts. But capacitive reactance given by the expression 2 pi frequency multiplied with the capacitance. So we're looking for the capacitance. Make the capacitance a subset of formula. We have 1 over 2 pi XC and frequency. Let's substitute the value. That will give us 2 pi is 3.142 XC. And we calculate at 24.5. 4.5 times the frequency is 50 hertz. If you do that using a calculator, that should give us 1.30 times 10 raised to the power minus 4 farad. This can be broken down into 130 microfarad. That is the capacitance of the capacitor. And then we have the last question, find the inductance of the inductor. The inductance of the inductor, which we don't know. The voltage across the inductor is given as this by the expression, the current, the inductive reactance. So let's find the inductive reactance given by VL all over I. VL from the question is given as 50 and I is 10. So this will give us 5 ohms. 5 ohms. Well, we know that the inductive reactance is 2 pi frequency and the inductance. So let's find the inductance using XL all over 2 pi frequency. We put in the values. This XL we calculate as 5. 2 pi multiplied with the frequency, which is 50. If we do that, our XL will be given as 0.0015 Henry, which is can reduce that to become 15.9 millihenry. 15.9 millihenry. That is the inductive reactance.